All right, it should be recording now.
All right, let me share my screen. Set up. Yep, excellent. Okay, so yeah, we'll try and get this one done in 20 minutes. It's a big subject, so we might go for a little bit longer. So what I'm going to talk about is this idea of mixed model arts, the idea of there are multiple data modeling patterns out there now. What are they? When would you tend to use them? Big shout out to Joe Reese, who kind of gave me the idea for this MMA. It's one that he's been thinking about for a while. And this is part of what we call our way of working. So I spend a lot of my time coaching data and analytics teams around agile patterns, so agile data and product patterns. And way of working kind of came out from a guy called Scott Ambler a long time ago. So just again, a shout out to Scott for that awesome term. As with all things data, people are opinionated. We certainly seem to be a profession that has a lot of opinions, and it would be fair to say that I'm highly opinionated on which data modeling patterns I like. So that will probably come through the presentation. But each of the modeling patterns have value, right? And the key question is which modeling pattern fits the value that you need, right? So again, just when you hear me have some bias towards the patterns that I love, just ignore it, right? Because that's just a personal bias. The way I think about ways of working is I think about a pattern library. So we have patterns that help teams form and store, and we have patterns that help teams plan what they're going to build, design it, build it. We have patterns that help us build out our data platforms. So we can bucket those patterns in different ways, and then we can break them down to smaller ones. So we might have a pattern that of team charter, right? A way of getting a team to create a charter document about their behaviors and what's acceptable and what's not. So our ways of working should not be a prescriptive methodology. It should be a bunch of patterns that we put together to help us work in a better way. And so below that way of working, below those patterns, what I think about is a data value stream. So every organization, every team's data value stream works differently. But the key thing is we start with an idea from one of our stakeholders, and then we do a whole lot of work to deliver data and information that has value to realize the action and the outcome from that idea. So this is a very high level value stream, right? You know, around discovering what they want through to building it and then ideally decommissioning when it's dead. When we work with teams, you know, we'll see much more detailed value streams, and we may see multiple value streams. We might see a prototype value stream where we go and do some work really quickly to get feedback, then out to a production one. We might see ones that are quite technical. For today, because I've only got 20 minutes, I'm going to talk about data modeling patterns focused around the design and a little bit of build, but we're not going to go into a lot of detail about the patterns themselves. We're sitting more at that conceptual level. From a value stream point of view, the next thing I think about is a data factory, and I'll use this later in the presentation. So data factory is where we use tools and machines to automate some of the work that we do as humans, where that has value. So this is where we might see our data architecture about collecting some data, landing it into a certain area, modeling it, presenting it, and then consuming it, right? So we might see our techniques for CI/CD, our version control, all those patterns that we use to get the machine to do some of the work so we don't have to do it. So that's how I think about these things. Bunch of patterns. Patterns have value. We use those patterns as part of our value stream where it makes sense. Where we can, we then automate some of those patterns in the factory so that we don't have to do the work ourselves where it's repeatable. So why do we model, right? Well, we model ourselves because we have this idea of defining something once and reusing it often, right? That typically just makes sense to us as data professionals. But when we talk to our stakeholders, that's an inward facing conversation, right? I model because it makes me more efficient. So, you know, interesting one that was actually triggered from the group and the community was, if we were presenting why we model to a stakeholder, what would we say? And this is typically what I say, right? Is that actually we define it once and we reuse it, makes me more efficient. Why do I do that? Well, save money because I don't have to spend so much time doing it time and time again. But also by modeling, we in theory get the same answer to the same question, right? So that reuse has value to our stakeholders. So the lack of data modeling Well, so at the moment, what we do in the market, we go through waves, and it'll be fair to say at the moment that there is a wave where, as part of the modern data stack, we kind of lost the art of modeling to some degree. And this is that idea of reuse. And that's not unique because Lawrence Core wrote a book called The Agile Data Warehouse Design in 2011. This diagram's from that book, and it's the same problem, right? Where he was talking about the fact that we would constantly rework the same problem every time rather than define it once and reuse it often. In my view, we probably don't have such a problem with re-extraction of data now. I think we got quite good at extracting the data once and landing it and reusing it. But in that ETL process, in that modeling, in that consumable layer where we present it out to our stakeholders, we typically see lots of rework in there rather than define it once and reuse it often. So the idea of data modeling provides a bunch of benefits, but one of those benefits is if in the middle there we can model our data, then we can use it more often on the right with less effort, right? So we're quicker, we're faster, we're more repeatable, and in theory, we're safer. So when we talk about data modeling, I'm not going to go and define what a data model is because actually that becomes a really big interesting argument. So I'm going to say that there are 5 data modeling techniques that I'm aware of, and there are a bunch of others, right? We have the Unify Star Schema, we have different ways of doing ensemble modeling like Anchor, but I'm just going to focus on these 5 and kind of go through what they are, how they differentiate themselves, and what I look for. So I'm going to talk about relational modeling from COD, dimensional modeling from Kimball, Data Vault modeling from Linstead, activity schema, and One Big Table, right? Because One Big Table is kind of Excel, and it's one of the most popular modeling techniques out there still. So before I do that, though, I want to talk about a shared language, because when we talk about each of those modeling techniques, they all have their own language. And so what I'm going to give you is a shared language that I use that then maps against each of those modeling techniques, so when I can compare them, right? And when we talk about a shared language, I come from New Zealand. I sometimes have colourful language, as in I swear. If I do, I apologise in advance. I try not to. But the other thing is we can actually use colour to help us identify the language. So this is a Data Vault model. And in Data Vault, we have 3 objects, hubs, sats, and links. And one of the techniques we use is we colour code them. So we go, links are green, hubs are blue, sats are yellow. Now, what that means is visually I can look at this diagram and I can go, oh, great. So I know that there's 2 links because there's 2 green boxes. I know that there's 3 hubs because there's 3 blue boxes. I know that there's 4 sats because there's 4 yellow boxes. I know that my product hub on the left there actually has 2 sats bound to it. So this visual color coding actually helps us look at a big diagram and get some insight and some language off it. So I'm going to use color as we go through to help understand these models. Because each modeling techniques use different terms, you know, entities, attributes, DIMs, facts, hubs, sats, events, activities, I'm going to use a language that we use from an agile data way of working point of view, which is concepts, details, and events. Yeah, and they're going to be blue, orange, and green. So concepts are the things in our organization that we see and we want to manage. Yeah, we may want to report on them, count on them. So they are things like customer, product, supplier, order, payment, store, those kind of things. Detail, as you'd expect, is detail about those things. Yeah, they're effectively attributes. So customer name, customer date of birth, product SKU, product name, product type, order quantity, order value, payment amount, right? Those details that describe those concepts for us. And events are the relationships. It's what Lawrence calls the who does what. So customer orders product, right? There's a customer, an order, and a product. That's 3 concepts. When we see that together, that's an event. Yeah, it's a core business process. So customer orders product, customer pays for order, store ships order, those kind of things, right? So I'm going to use those terms interchangeably as we go through each of the models. I'm going to do one other thing that's probably going to freak you out a little bit. So I'm just going to explain what it is. So on the left, I have an enterprise, an ERD. So yeah, I can share the slides afterwards. Yep, no problem at all. So an ERD is a way of describing a data model, and the way it works is each box is effectively a conceptual, logical, physical table. the top we have the table name, and then going down that box we have the fields that are sitting in that table. Yeah, so I can see in there I've got 6 tables, right, with a bunch of fields in them. On the right hand side is effectively Excel, right? It's the way so an engineer may look at the left hand side and be familiar with ERDs. On the right is kind of what analysts think about, right? Is I have an Excel spreadsheet, my field names across the top, and then I have data examples going down the page. What I'm going to do when I describe the models is I'm going to use both those techniques. So I'm going to use the middle one. I'm going to give you the field names as if it was an Excel spreadsheet. So the fields are going to go across the page. I'm not going to give you data examples, right? But where you see a row in the next diagrams, they are effectively a table. Yeah, that makes sense? Cool. Right, we'll have a go at this. So let's look at some modeling patterns. So this is a relational modeling pattern. Yeah. This is a very simple relational modeling pattern. Yeah, we typically will see an ERD or relational modeling pattern with lots and lots of tables, but I've dumbed it down just so we can describe it. Each one of those rows is effectively a table, and we can see that the customer table at the top there has this concept of a customer and then a bunch of detail about it, their name, their date of birth, and that's bound to that same table. We see down the bottom we've got product again, right, concept of a product, and then a bunch of detail or attributes about that product in that table. So both our concepts and our details are bound into a single table, and then we break them out, right? And then when we have an event, a table may relate to an event or it may not. So I may have a table called order, and I may have a table called order item, and that may actually be an event for me. Yeah, so customer orders, that's an event. And then we use foreign keys and primary keys to relate all the data. Now, the challenge with this is it's great from a modeling our operational system, a little bit difficult to use for analytics, but the model itself doesn't tell us where those events live. And most of our data modeling when we do analytics is around events, who does what. So it's useful. 20 years ago, we used to do our middle layer, used to always be, we were in the Inman versus Kimball war. There were lots of people that do relational modeling as their conformed or their design data, and then Kimball for the presentation layer. So that's the relational model. If we then go to a dimensions model, what do? Well, we say, actually, why don't we make that event actually a thing? It's a table I know exists, and let's call it a fact table. So I have an event of somebody ordering. I'm going to create a fact table called order. In that table, I'm going to hold a bunch of concept keys and actually detailed keys, but we'll get onto that. And I'm also going to hold the detail about that order. So the unit price, the quantity, amount. And then off that, I'm going to hold a bunch of other tables, right, which describe concepts. So I've got a dimensional table is what we call them. And so I've got a table of customers. I hold the customer ID and all the detail about the customer. I've got one for product, and then I combine those together with joins to give me my model. In dimensional models, we sometimes take a piece of detail like order status, and we break it out as a thing, as a table on its own, as a dimensional table. Because from a modeling point of view, that has some value in doing that, right? So we'll see a mix of the dimensional tables be core concepts and actually be detail or attribute about those concepts. And of course, this is a simple example. One of the challenges then is we end up with multiple facts. So we end up with a fact for customer orders product, which is the order fact. We'll end up with a fact for customer pays for order, which is the payment fact. And then sometimes we've got to slam those two together to say, what's the time between the order and the payment? Yeah, and that's where the complexity comes in. We end up with shared dimensions, so that customer is used in both the order fact and the payment fact. And again, we start getting a bunch of complexity. But this is a simple way of describing in my head the pattern for a dimensional model. Okay, so let's rip over to Datavault. So Datavault is a form of ensemble modeling. There are other ensemble modeling patterns such as Anchor and a few others. And what we do here is we have 3 objects. We have hubs, sats, and links. And so let's look at the hubs first, right? Hubs hold our concepts, but all they ever hold is a unique ID for a concept. So if I look at a hub for a customer, what I always see is just a bunch of customer IDs or keys. I've seen some other metadata, but just the ID. And then we have satellite tables. They hold the detail about that customer. Yeah, so they hold the name, the date of birth, and they're keyed off that ID. Now, in Data Vault, one of the things we can do is we can have multiple satellites. So if you look at product, we have a product hub, which is the keys for the product. And then we can have multiple satellites which hold different details about that product. And we do that because we might want to do it based on rate of change. We might want to do it on PII data. We might want to do it on large text fields versus numeric fields. There's a bunch of optimization reasons that will break those sets out. So hub, bunch of keys, sats, detail about those concepts. And then we have a thing called a link, which is the relationship. So that's the who does what, customer orders product. And all we hold in there is just the keys. Yeah, so we're just those IDs. Now, again, we're going to end up with multiple links, right? So we're going to have a link for customer orders product, a link for customer pays for order, a whole lot of other link tables, so it gets messy. The other thing is, as with all modeling techniques, there is a bunch of arguments in this domain, and one of the arguments is around this idea of a link set. So I prescribe to a modeling technique that doesn't have satellite tables hanging off my links. I bind them to what I call a core instance hub. DV 2.0, which is the official standard for Data Vault from Dan, says that there are link sets, right? So if you're going to the Data Vault world, just remember that there's a couple of different ways of doing it. The core thing is Data Vault always has links, hubs, and sets, right? They're the core tables and a bunch of other ones. We go from there over to the next one, which is activity schema. So activity schema is kind of interesting because what we end up with is just one table. And so what we do is we have the core part of that table is a piece of detail, which is the event, date, time. Yeah, so every time that's kind of one of the key fields on it. And then we bind the activity schema table to one and only one concept. That's typically customer, but might be product or something else. But there is only one core concept driving that table. And then sitting next to it is the event. Yeah, so I can see that this customer had an event called order, this customer had an event called payment. Now, the reason we do that is now we've got this racked and stacked table that we can move up and down these events really easy and say, what's the first event, what's the last event, what's the events in between, how many events happen between those events. And there's actually within the activity schema a whole predefined set of metrics that we can just call because the pattern for the table is prescribed. Now, with activity schema kind of version 1, we were binding some other concepts in there. I think we had 2 other fields we were allowed to use concepts. So we might have product and we might have store. And then everything else kind of got put into the attribute field. With the new version of it, the model is kind of, we use a JSON blob object to hold both those additional concepts and those additional details in a JSON object, which gives us a bunch more flexibility, but a bunch more complexity, right? So that's what activity schema is about. And then we rip into one big table, which, funny enough, as you would guess, it is one big table. And what we're doing there is we're grabbing all the concepts, all their details, the event, and just smashing it and denormalizing it into one massive large table. So we'll see customer and all the details, order and all the details, product, all the details in this one table. Yeah. Right. So that's the models from a visual point of view. So the key thing is, as data engineers, if you get into the space, you need to pick your models. And I've just described 5, and there's a few others out there. So what I suggest you do is you figure out first where you're going to use a model. And once you understand where it sits, then figure out which model best fits that need. And what we're seeing now is that in the past, we would typically pick one model, and that would be the one model to rule them all. So yeah, we go, okay, we're going to go dimensional modeling with star schemas and Kimball, and everything's going to be a dimensional model. That's no longer true. We now look at mixed modeling, right? We say if we have this specific type of use case and it's common, then this modeling technique may be the best way of doing it, and we have multiple models within our data platforms. So if we look at it, our natural reaction is to go, okay, let's look about whether we're modeling the source data, we're modeling the the data based on a report or an analytical machine learning model we're going to build, or we're doing it based on our core business processes. But the challenge with that is I can take any of those modeling techniques I talked about and apply them. I can data vault my source data. I can third normal form it. I can dimensionally model it. I can use activity schema as the way I present my data to my reports. I can use data vault. I can use star schemas, right? Each of those modeling techniques can actually be used if we take any of these lenses. So it's not particularly helpful for us. Some of them do naturally fit more one of those lenses, but typically you can use them anywhere. So what I talk about is the data factory, right? And a data factory is we collect some data, we store some data, we do some bad things to data to make it fit for purpose because it's messy or it doesn't match our organizational ways of working and our business processes, and then we make that data available to be consumed. Yeah, so think about that flow as a factory. So an example I use is a laundry. You know, we get all these dirty clothes coming in because our data is always dirty. They get dumped into a big room. We then go and sort them on the shelf in terms of colors and whites. We then might go and, you know, clean them up a bit. Then we go and press them. We kind of combine them. So that's an outfit. And then we make that ready for somebody to pick up and be consumed. So from an agile data point of view, because we've actually built a software as a service product, which is what our core business is, we use three models. So our data collection, we go and grab the data from source systems and we bring data into what we call a history layer. Other words you might hear for it is raw, bronze, persistent staging area, data lake, those kind of things. And when we do that, we adopt a relational-ish model, right? And I'll explain why it's ish in a minute. So we just rack and stack that data. And then from there, we have the data in a designed layer. And for us, we use Data Vault-ish. Like I said, I'm a bit of a bigot, and Data Vault's my favorite technique for that. And then when we're making the data available to consume, we typically bring it out as one big table. But depending on the tool and the customer, we may actually present it as a dimensional model because that's what they're comfortable or what the tool prefers. And we're just experimenting with activity schema for event reporting, right? Where we want to go first scene, last scene, between, see how we incorporate that. So we're actually using 3 core modeling techniques at least, and then 2 other optional ones where it has value for us. So what does that look like? Well, data comes in and we basically map the table we've seen from the source system. So if it's from a relational, you know, Shopify, we'll have a customer table and an order table. If it's from Google Analytics, we'll have an event table. Why I said it was relational-ish is we don't hold any primary or foreign keys in there. So we treat the customer ID as just a piece of detail, right? It's just another field which we can use. From there, we moved into the design layer. So we have links, hub sets all the way through, and we model based on that. And then we will then take that data and make it available as a consume layer. So we will say we've now got this one big table of customer and all the details. We have a table or a view, which is customer orders product and all its details. And we hydrate those dynamically. So we can map from the data vault to those tables without us having to write any additional code, because the pattern of customer hub and set can be denormalized out to this pattern of a customer table and all their changes over time. So we've programmatically done that in our factory as an automated piece of code, so we don't have to do that work anymore, which is one of the benefits. Now, there's a whole lot of downsides on this. For example, one big table with a whole lot of change records for the customer is gnarly. And so there's some downsides every time you pick a modeling technique. So what we need to do is we need to say, well, what would happen if a ninja went up and fought against a Spartan? Who would win? And we use that technique to decide the modeling technique that works for us. So I'll give you an example, right? And this is a very simple example, and there's a whole lot of complexity here and edge cases that you're going to throw at me in the Q&A, I'm guessing. But if I said the 2 things I care about is managing change data, and by change data, I mean details change. So when a customer changes their name, or when the product changes its product type, I want to be able to track those changes over all time. It's the first thing I care about. And the second thing I care about is query simplicity. How easily can a user query the data? So I go, okay, relational. Well, actually, we can do change data management in a relational model, but it's a bit of a pain in the bum. It's not native, right? So we can design for it, but I give it a 1 star, firepower 1, yeah? Query simplicity, well, we end up lots of tables. Somebody's going to do party entity or things in attribute of a thing. That's a horrible thing to query. So I'm going to go again and say, in my view, it's a 1, right? So I'd probably not use relational for managing change data or for the consume query simplicity. From a dimensional point of view, I'm going to give it 4 stars for change data because we have slowly changing dimensions type 2 and type 1, right? So it's kind of built into the model. And here's the one that's controversial. I'm only giving it 2 stars for query simplicity. Everybody tells me that everybody can query a star schema, but actually that's because they've been taught. There's a lot of joins you've got to understand, are you bringing back SU2 or not, right? There's a whole lot of complexity for the user, which we can teach, and that's fine. For change data, for Vault, 5 stars, right? That thing, you can't have a data vault if you're following the data vault standard that doesn't have change data in it. The SATs are natively type 2s, and you can't override that. But for query simplicity, it's horrible. We end up with this massive number of tables, and I've got to join a link to a hub and a hub to a SAT. Multiple SATs in there, and now I've got other link tables. So probably never surface a data vault to you end consumers, put something on top of it. Activity schema, it doesn't handle change data. There are ways to do it, but we've just got an event, and if the customer's changing their name all the time, it sits in that JSON object. Yeah, so that's a bit of a pain in the bum. Query simplicity, if all we're doing is event reporting, it's great, but if we're using it as a hammer for every type of reporting, then I only give it 3 stars. One big table, it's rubbish at handling change data. If you think about it, I've got customer and all their changes, and then I'm going to replicate every audit for that. And then as a user, what the hell am I going to do to get that out? So if I'm doing point in time reporting, one big table is good. Change data, it's not so good. From a query point of view, there's no joins. I just go hit it, but there's still some complexity. I've got to understand that if I want to count customers, I've got to count distinct. Yeah, because my customer's been repeated. I'll probably go and should hit the customer table. If I'm slamming multiple one big tables together, there's some complexity in there. So the key thing is figure out what's important to you, and then go through the models and say, okay, in this area of my data factory, this is important to me, this model fits. Sometimes trade off, right? Because we don't want 100 different modeling techniques. Sometimes we go, well, I love Data Vault, but actually everything else we've built is dimensional. Our code base is dimensional. We'll just reuse dimensional because that gives us bigger reuse. But that's a conversation you should have as a team. And so for me, that is Mixed Model Arts, MMA of data modeling. Open to questions. I'll stop my sharing. Actually, I might leave my sharing on in case I need to go to a slide and point it up.
All right. Let me stop recording first.